Hi everyone, I'm Matteo Collina, Platformatic co-founder and CTO. And today we are going to talk about how I combined node tests with TypeScript. So let's see. So before we start, who I am I'm Matteo Collina, part of the Node.js technical steering committee, and also a board member of the OpenJS Foundation. However, all of these are my opinion and my own, as the lawyers will say. I also I'm also part. I have also created two libraries called Fastify and Pino, and there's many others on that are all available on npm. This is probably more very famous, so you probably are using them or heard about them. And I have a past as a consultant. Then I decided to do my startup, but we'll talk a little bit about that later. And you can subscribe to my newsletter at nodeland.dev. So I gather a lot of downloads on npm over the years. I've been part of this community since the very early days, and in fact, I have very close to 5 million downloads per week or something like that, and these accumulated to 22 billion downloads in 2024. Which in 2023, which is essentially an impressive amount, okay? And it's unbelievable. So it's totally unbelievable. So you all are using my software, so I'm very grateful, but I have a confession to make. And it's that before 2022, I never used TypeScript. And I stayed away from it big time. So, and now I'm doing talks about TypeScript. So what happened? Well, in 2022, I decided to, with my co-founder, to do a startup. And the problem that we were focusing on is backend development and how the time of backend developers is spent, and how much time is spent on valuable features versus the platform infrastructure that they need to get set up. So reality is that you need to do API clients, boilerplate update, local development, monitoring, documentation, log out, authentication, and so on and so forth. It's actually a lot. So we try to simplify all of that and provide easy to go solutions that are developer friendly. In fact, Platformatic is a set of tools that allows you to move from A to B very quickly, essentially get your product shipped. But the way it does, it allows you to essentially have a very, very fast, high-speed train to get to some intermediate point that will get you, I don't know, a lot of 80% of what you need to do. And then after you got with your 80%, we give you a nice electric SUV to go for the last few miles, which is also very fast. So anyway, without further ado, why does it matter for TypeScript and tests? Well, because it's a DevTools company, and if you're doing DevTools and not doing TypeScript, well, you're doing it wrong. So I got to learn and start doing TypeScript, and then a problem emerged. And the fact that, when Node.js shipped the Nodetest framework, I wanted to use it, and I wanted people using Platformatic to use Nodetest to test their applications. But there was a problem, how to integrate it with TypeScript. So we'll talk a little bit about that later and the challenges that I have. But let's talk a little bit about Nodetest. What is Nodetest first? So Nodetests is a new test framework for Node.js that shipped last year or the year before, and it's stable now. It's really great. It supports both synchronous and asynchronous tests, but the asynchronous test does not support callbacks. It only supports promises. It's great. We also have our own assertion library called Nodeassert. I think it's really nice to work with this because it's really, really fast, especially with JavaScript. It's with JavaScript is as snippy as you can imagine. You just take a few milliseconds to run your tests. Great, we love it. Now, what's the problem though? Okay, or where are we? Well, we'll talk a little bit about the TypeScript problem in a moment. But you can use your tests. You can have nice assertions, nice output, multiple stuff. You can run your tests one at a time, which it's great. and you can see that you can specify only in the test, and then you need to use the node --test only in the command line to match. So, and to tell the node to actually look for that option. If you want to run a suite of tests, not just one file, you can use the node-test flag. It's phenomenal, but especially on Node 18 or Node 20, it's the patterns that you look for are not that great. So we'll talk a little bit about that in the next couple of slides. But it looks for a test folder, for example, or a file called test.js, and it runs them. And in fact, Node.js as a test runner is phenomenal. Let's recap. So if you do node test, you can use all node options to debug your program, including, for example, --inspect. I love this. Like, this is phenomenal. I don't need to configure various hard options to have my tests run with the inspector. Wow. I can also do inspect break. So I could actually break my tests, break at the beginning of the execution of my node process before even the test framework is loaded, so I can debug all the things and I can investigate what's happening. I can use node debug, I can use debug, I can pass anything environment variables that I want, because it's just node. It's just I don't have a wrapper command to do it. It just works. I can also use profilers. Okay, so if I want to profile my software, I can actually do that. This is really important. All of this is really important for the individual test file, so that I don't need to have any what you see is what you get type of thing. What you code is what you run. Okay, and this was great for JavaScript files. Okay, so again, the problem, keep it in your hair. What do you do with TypeScript? So in fact, there's the node-test that runs all the test file according to a predetermined glob pattern in the file system in parallel. Wow. And if you test, we talked about test only, and we need to talk about test concurrency, which limits the number of parallel tests. Why you want to set it to 1, for example? Because if you're talking to a database or another system that has state, you don't want your tests to conflict with each other. However, that will slow down your tests significantly. So be careful. Also, there is watch mode, so you can actually reload your tests when it changes. Lots of people like this. I don't use it, but a lot of people really like this feature. In Node 21, so it will be in 22, you will also get the glob pattern support. Wow, finally, okay. We can also use Nodetest to create test suites, so you can use the scribe to create a test suite, and then you can still call test to in turn inside the suite to do the things. Loving it. It's pretty cool, right? And you can see that running this thing on my laptop, it takes, I don't know, 5 milliseconds overall. Okay, it's pretty neat, I would say. Well, you need to add the time that it takes to start Node and whatever, but it's pretty neat. Okay, so you can also do the same kind of thing with using subtests. So, and that generate the same output, but this allows you to use a weight, for example. And in this way, you can even align them with some other commands inside the suite. Useful. I've used this in the past when there was state between the tests. There is the phenomenal thing, which is called reporters, which allows you to change the output. Very easily, you can use the reporter tab, dot, or any node modules that implement the same pattern. We love it. We use it. We have support for mocks. And mocks are great. Don't rely on them too much, but they can help you test certain kind of error conditions or certain conditions that are harder to reproduce. So you can create your mocks. Note that the mocks are attached to the test context. What is the test context? Is the parameter of the test function, the test callback that you have passed in, and so that the mocks are reset after they finish. It's a very good pattern, and it's provided as in the system. You can also use the same pattern to mock timers. Now, mocking timers is hard. And yeah, we support it. It's done. It's there. Great. And we also have embedded code coverage in the system. It's still experimental for various reasons, whatever. And I personally still use C8, but this is available, okay? C8 is another test, is another code coverage analysis and so on and so forth. And I actually prefer it, but right now, at least. But the real magic happens with the run function from Nodetest. Run function takes an array, a group of files, and you can use it returns a stream, which you can use to call, to compose with the reporters and pipe to the output. Wow. How does it work with all the things? So you take your reporter, which is tap and spec, for example, and then you take the run function from Nodetest, and then you get glob, which is a module on npm that we need to use. And if it's is TTY, if it's a TTY, which is if there's a human, we use the spec. If not, we use tap as an output, and we compute our globs, and then yay, pretty cool, right? But how do we use it with TypeScript? Like, does it work with TypeScript? Well, let's try. Let's do a few tries. So first, well, no, it doesn't. Well, not necessarily true. If you're running one single file, it does work out of the box, because you can do node -- import tsx, for example, and the single file will run. Why? Because we load tsx, and then the default pattern, we don't do any globbing, so we just run the file, and with tsx register as a loader, we can run them. These are still super fast. Like tsx is blazing fast, and therefore everything is fast. However, if we try to run the run the -- test flag, which means the suite, we get nothing. Absolutely frigging nothing. So, ouch. Well, if we use a Node 21 plus, we can use the glob pattern to tweak it. Maybe it will improve in the future. Right now, not good. And if you need to support the old versions of Node, you are a little bit stuck. Okay. But, well, actually, it is possible. Okay. And in fact, you could, for example, set configure a loader, for example, TS Node. And if you use TS Node, which runs the full TypeScript compilation and so on and so forth, it's great. It can detect problems. You can set it to node options and then run your program. You run your test suite with your globbing for .ts. Now this is great because what this does is alter the current process node options. But because the environment variables are inherited to children, we are essentially those will be passed through the child tests, and therefore you will get the loader set up, and in fact all of that works perfectly. However, it's slow. Why it's slow? Well, because there is the main process running, and you have each one of the test files is run as its own child process, and each one of them has its own loader, and each one of those loaders run TS Node, and it needs to compile the TypeScript, do all the things. So it's very slow. Okay, this approach is an approach that unfortunately it does not scale. So what do we do? Well, one option could be to use TSX, but these will skip type checking because TSX only uses ESBuild. So is it something that we want or not? This is, to be honest, part of your development workflow. So who am I to say? Okay. I genetically prefer to have my tests type checked before running them, right? I don't know. This is what I would do. If I use TypeScript, I want type checking. So anyway, however, what we can do is, the question is, do we need a loader at all? Well, we don't. okay, what we could do, we could run the TSC, the compilation in the main process, and then just spawn one targeting the the JavaScript files. So it's fantastic. Also, because TypeScript can have incremental mode on, so we could actually recompile it faster in case of larger things system. Now, going back to our system, to our tool, I have written a tool to set it up for you, which is called Borp, which is a test runner on top of Nodetest. So how does it work? Well, you can just use npm install it, and then you can run it with -- coverage, for example, to have the coverage set up and integrated. And in fact, Borp just use TSC, okay? And it provides full type checking before running your tests, okay? And look, I love this this meme, because it's we said we need to do this faster, and everybody said write it in Rust, write it in Vig, and the person that's used basic caching or skipping was thrown away. And this system is actually what it does. Okay, it's he said, you know, we are just running the JavaScript files. Okay, we are not running the TypeScripts anymore. So it's great. So yes, so to recap, Borp do automatic TS detection and compilation using TSC, run TS test directly, so you don't need to worry. It supports globbing and coverage, and multiple reporters out of the box. Also, it has, you know, I tend to recommend this kind of directory structure for TypeScript. I will talk a little bit about that in a second, but this allows a nice symmetry between your SRC and dist, so you have actually good resolution for all the other files in the main directory. So, bonus tools. I thought I would talk about Nodetests. Bonus tools. The first one is an utility called TSPL. TSPL stands for test plan, and test planning is very important, especially if you're testing any kind of events-based system. So you want to verify that a function was called or an event was triggered. It's very important. It's not part of Nodetest yet, and therefore I had created this utility to do it. I use it all the time, so you can too. Okay. Also, I also created this utility called Snap. Snap is a tool that lets you do snapshot testing, and it just works. It's you pass in the object, and if it's not there, it stores the snapshot. If not, it returns the actual thing, and that's it. Last but not least, there are a full set of reporters that are available from Moshe, Molo, or Molo on GitHub. Molo is part of the Node.js TSC and one of the maintainers of the test runner, and he created a huge set of reporters. My favorite one is called @reporters/GitHub, and basically when you run your code on GitHub Actions, you get inlined, you get the errors inlined in the code when you are actually reviewing the PR. This is unbelievably good. Okay, to be honest, it's a killer feature for GitHub Actions essentially. So I absolutely love it. So now it's time for the demo gods. So here we go. Okay, so this is an example repo. We have an SRC and. And now it's time for the demo gods. So let's see how. Let's put Borp into action. So first of all, we are in an empty folder with a tsconfig file. So I'm going to create an src folder, and then src lib, and make the src test. Okay, so we have our test stuff. And here we have those two things. Okay, so let's start writing a little bit of an app.ts, which is a Fastify app. So let's do import Fastify from Fastify. Then I can export a sync function create app. Okay, let's call it build because I prefer to call it build, but this is me. And this create a Fastify app, and then it returns it. Now I also need to import a type. So type Fastify Fastify server options. Okay. Here we go. So here opts, yes, and opts. Okay, so we can pass them through. And now in our tests, let's test this. Okay, how do we do this test? Let's call it app.test.ts, and we can do import test from Nodetest, and then import assert from Node-assert test. It should work, yeah. So let's call it root endpoint. And this is an async function. Then we can create our app. Oh, we need to import it. Import build from libapp.js. So we do await build, and then we inject. We use the injection from Fastify status code, and we verify everything works. So if I've done my job correctly, I can do npx borp, and it's failing. Oh yeah, because I made a mistake, a typo, and now it's working. And in fact, you can see it's failing because I use strict equal and not strict deep or deep strict equal. Here we go. So now we run it again, and you can see it's running very quickly, and we can do even code coverage. You know, everything's done, set up. So seems pretty great. Okay, so why do we? And you can see now that we have created our this folder, and we have our tsbuild.info, which is needed for incremental mode, and we have our files in here, and so on and so forth. Note that this structure more or less is the same structure that you will have for your production environment. You might not want to compile tests, but that's kind of the same thing. So I think this works very well for to have a one-to-one system between development and production. So then what other features are very useful with this? It's we can, for example, add Fastify Static. Okay, so we want, let's say that we want to create a static test.ts, and I'm going to copy this. Okay, let's say that there is a public folder here that include a file.txt, which can be generically your CSS file, to be honest, and it contains a string called hello. So here I can do test serve static files. Okay, and now here I can say, for example, I want to public file.txt. Okay, and here is a strict equal and response.payload, and we call it hello, and these, let's see, this should be it, right? Oh, wait, I didn't configure, it's failing. Why? Well, I didn't configure anything. So I actually need to import Fastify Static. Well, this used to be correct, but I need to change it. And then we need to use root, and I need also join. Okay, and now I don't need to do any of this shenanigan, which seems very odd. I can do just import meta dir name. Thank God. Oops. And then I need this dot public. So, and you see this is right because this type of path will work if we're both inside src and inside lists because it's the same structure. So hey, and now it's failing, still failing. Why? Let's take a look. Oh, of course it's failing because I haven't set the prefix. So I need to set the prefix and call it public. And running it again. Oh, wow, it's passing, but it's missing a /n. Huh, cool. Here we go. Editors are fun. Yay, okay, we have made it. Pretty nice, okay? And we can, we can really go on for quite a while with this pattern. It's work from my point of view super well and so on. I want to show you a couple more things that are very useful. So for example, we could implement a snapshot testing. So we could do, let's so go back here. Let's say, well, this is fine. And so we could implement snap from at Matteo Collina. Oh, snap. Okay. And here we need to create a snap function, which is snap and passing in import meta URL. And now let's say that we can do, for example, snap. Oh no, sorry, I made a mistake. Okay. So instead of doing this, instead of specifying what we want, we can do snap and response payload and await this. So what this will do, it will on the first run, it's basically a true equals true scenario, but after that, the file gets stored on disk, and each subsequent one will actually have the file stored on disk. So seems pretty cool. And this still works, but if we go and change our file, for example, now it will fail. You see, it now failing. Cool. Very useful. I think snapshot testing is a very, very useful feature. Let's see, for example, instead how you do the test planning with this set of utilities. So let's say that we can add another route here. So let's say let's call it target, okay? And we want to get the result from a fetch endpoint. So, and we need to do, we need to pass a URL here. How do we get a URL? Well, I need to do is Fastify server options. So app opts, and I need a target URL string, cool. And here I want to be app opts. Great. So now I can do app. So opts dot target URL. Cool. And this is not needed. Everything will be forwarded correctly afterwards. So in my tests, I can target endpoint. Here we go. Target URL. Well, I don't want that. So I can do just target. And it's a Fastify app. And let's add a route. Yeah, that's great. However, we want a test plan. So we want to verify that function is called. So we can do import TSPL, actually, yeah, from Collina TSPL. And we do const plan. And we say plan 1. This is great because then we can do plan pass target called, and at the end plan dot complete await plan dot completed. And we need something that needs to be done because it's it will be listening this function at this server. So it's t after target.close, because we are calling it to call listen here, and await target listen. Here we go, port. Like it can get very quickly complicated, and then we can do target.listen in origin. Sorry, why? It's origin. Okay, here we go. Okay, so we have done that. Okay, now let's try running it. Oh, it's expression is not callable. Okay, so let's try with npm TSC. Probably gives me a little bit. Oh yeah, made a mistake here. This is likely I need to do this. Okay, cool. And oh, let's do this. Here we go. Okay. And it's not there. Made a mistake. It's okay, I think. Yep. Then I am import type plan, because I don't know why we can't have good things. Here we go. Now it's compiling, so I can actually do Borp coverage. And now it's passing. It's even detecting that we are a little bit of something that's not being covered, which is in fact the hack that I've done to have it forcefully casted. Cool. It's amazing. And you can see that we have a snapshot file over there, which is our snap. And that's it. Thank you for watching. And it's been fantastic. Please check out platformatic.dev. And, thank you and see you next time. Bye.